Good morning, meteorology. I decided that today I could go back and do a little bit of map discussion and then show you guys a little bit more about drawing contours. Um, if we look at the radar today, looks like Georgia is pretty clear, and actually, we're probably what you can see down here is the radar actually picking up a little bit of that lower level fog this morning because we're definitely not having any big clouds up there right now. Um, if we look at the current summary, we can look at today's map. We have a little bit of a colder front moving off. We don't really see a lot in the Department of Winds. Let's see if we can move that a little bit better. And we do see a little bit of a low pressure system coming through over here. So we can kind of keep track of that as it comes in. But yeah, really no winds over the southeast right now. Looks like we'll be pretty clear. So what I wanted to show you guys and give you a little bit of examples is when we draw contours for pressure, sometimes those can look a little bit trickier than what we see when it comes to temperature. The temperature contours that I did see that you guys have done looked pretty good. But I wanted to show you guys some contours, and I wanted to give you something so that you could all have something a little bit different. Um, and everybody could, potentially have a different map that they want that they would draw their contours from. So the first thing I want to show you is the website that I use for a lot of these maps. That website, and I'll link that to you as well, is vortex.plymouth.edu. So when we go there, this is our Plymouth State Weather Center, and within that, we can look at a lot of different things. So help yourself to look around and see what you can see. There's all sorts of interesting things, all sorts of radar images that we can look at, satellite. But the thing I want you to look at right now is the data archive. So the data archive is where we can find not just today's weather, but all sorts of archived data, old radar images, um, old satellite images, which is pretty cool. And so, what you're going to do is go to the surface section, and we see that we're looking at plotted maps, and you're going to select archived plotted maps. And we have these options here for what we want to pick. So most of this you don't really need to touch. I think it's fine to stick with the contiguous US. But we do want to change from temperature to, and eventually we'll do the station plot. Station plots are, that have all of the symbols. But what we want to do is sea level pressure. The reason we want to look at sea level pressure is because that allows us to analyze a lot better what we're looking at for a lower high pressure system. If we have a station pressure, that is the pressure at a certain station. So if one station is at a higher altitude than another, even though they're both on the ground, well, the higher altitude is always going to have a lower station pressure. So one thing that we do when we want to look at that is basically adjust our pressure so that we could say, well, based off of this pressure at this altitude, what would the sea level pressure be, assuming that you have a uniform atmosphere and nothing else is crazy going on down there. So we want to look at sea level pressure, not station pressure. Some other things that will help us is either do lowest density or low density. If we have too high of a density for a lot of data points, it's going to be very hard for us to really piece together. So for now, I'd probably stick with lowest density. That would make things easier. And if you make your map a little bit bigger, that would be maybe a little bit easier for you to um, make your contours. So once we've picked this, oh yes, and then the date. So we can go back, and so maybe you're curious about what the weather was like on your birthday, or I can go back to Cinco de Mayo 2005. That was my senior skip day. Um, and so, everybody can pick whatever date in the past is of interest to you. Maybe you could go back and think of your favorite Christmas. Maybe you could pick the day of your birth, or um, anything of note, the day you moved. And so now we can make the map. And so now we see this map that's got plots, right? So we can see all of the different data points. What I'm going to do, now you could print this and you could write on it. If you don't have a printer access, I don't want you to have to redraw the entire thing. So what I'm going to suggest is that you take this and then you open it up in something like Microsoft Paint, or some sort of sketching thing. So now that I put this in here, and I can even adjust it some more if I wanted to, I'm going to try to figure out how to draw the contours of pressure. So for pressure, we typically, especially sea level pressure, we want to draw these isobars. That's what we would call a line of constant pressure. We want to draw those at intervals, or each line is a different interval of about 4 millibars. So you would have like 1,000, 1,004, 8, 12, 16. And so it can be kind of tricky if you really don't realize where you want to start. But if you find like the highest and the lowest pressures, those are probably the good places to start, because then you can work your way out from there. So if I'm looking around, I see 1014, 1011, 1020. 1028, 1030. All right, so this is definitely where my highest pressure is. And if we're going on a, every 4 interval, basically the highest isobar I would have would be the one that would represent 1,028 millibars. So I want to come up with a line that would represent 1,028. Now, what I typically do in order to do this is I give myself a couple points, and then I can play connect the dots. So, for example, between, I'm not sure if you can see this, but this is 1028.7 and 1027. Well, wouldn't 1028 be somewhere around here? Between 1030 and, oh, well, this is 1028.7. So again, I've got 1028. It's probably pretty close to 1028.7. Between 1024 and 1030, I probably have 1028. Here's 1028.2, so that's pretty much right here. And so as I go around, I can kind of estimate where 1028 is. Here's 1030, here's 1027. Well, 1028 has to be in between these. 1028 has to be between these two, right? This is 1029, and this is, so we can kind of see what we got going here. So now that I kind of see where that 1028 line is, I want to make sure that everything on one side is higher and on the other side is lower. So if I kind of draw this now, connecting the dots, and I don't really know what's going on over here, but I can just kind of leave these to trail off out over the ocean. Now I can see, oh yes, everything inside here is higher than 1028, and everything on the outside here is lower than 1028. And now I've got my first little bar, and then things get a little bit easier from that point, because now I go to 1028. Next number is going to be 1024. So here's 24.9, right? 24.2, 1024. We got lots of 1024s over here. That's 1027, 1026. So there's no 1024s over here. And then we can see between 22 and 26, between 23 and 25. All right, so now that I've picked out a couple different points, I can go back through, and now I can piece together, right, my next line. It's probably going to be helpful for me to go ahead and make sure I know which what these lines represent. So I don't have to label it everywhere, but I could just say, yeah, this is my 1028 line. And I'm going to go ahead and put another one here, 1024. That is not sticking out. There we go. So then we can, continue this, and then we can see this. So what we're going to start doing as we keep on doing this is looking at where the winds relate to these pressure lines. But it's also just really important. What I want us to focus on now is just understanding what these lines are telling us. So that will be your assignment for tonight. Making these bars, these contours, now for pressure instead of temperature. All right, well, I hope you guys have a great day, and I will see you guys soon. I should have office hours up for tomorrow during normal class hours. So have a good one, guys. Bye.